All right, so the first section of Chapter 8 is all about what's called the zero product rule. So our goal for today is to solve equations that are already factored. So factoring, remember, is writing as a multiplication problem. So today everything's already written using multiplication. We're going to apply this new rule called the zero product rule, and then we'll move forward from there. Tomorrow we'll kind of combine what we already know and what we learned today in section 8.2. Any questions before we get rolling on this? All right, you don't need to write any of this down. This is just kind of what I already was explaining just a minute ago. So the whole reason that we learned to factor in Chapter 7 is because of the rule we're going to learn today. So factoring means writing using multiplication. Once you write a polynomial as a multiplication problem, you can use this awesome rule called the zero product rule. That's what we're going to look at today. Here is the zero product rule. You don't need to write all of this. I will just sort of highlight the important parts. So, of course, the title, zero product rule. This is the formal definition for zero product rule, so I want that somewhere in your notes for sure. And then the second bullet point is very basic description of what the zero product rule means. After you write down what is boxed in and what is starred, I want you to read through everything else. We'll discuss it in a minute. But for now, just write the starred material and read through the non-starred stuff. Okay, if you're still writing, that's fine. I'm going to start explaining for those of you that are done already. Does anyone remember what the word product means? Multiplication. So today we're only talking about multiplication problems. Very good. So, two important things have to be going on today to use the zero product rule. The first one is a zero. It has to equal 0. The other thing that has to be true is a product. It has to be written as a multiplication problem. So if you have 2 numbers or 3 numbers or 4 numbers, any amount of numbers, any number of numbers, being multiplied together and equal to 0, one of those numbers has to be a 0. So either the A could be a 0 or the B could be a 0. So what we're going to do today is we're going to figure out what makes each part of our problem equal to 0. And the reason this works is what's written on the bottom. What's 0 times any number? 0. What's any number times 0? 0. Is there any way to make a 0 using multiplication without a 0?
Can
like
you multiply 2 numbers together and make them equal 0
without,
those numbers
yeah.
aren't zeros themselves?
Yes?
What?
Oh, no.
No, you have to have a 0. The only way to multiply to get a 0 is 0. 0 times anything is 0. So that's why this works for 0. 0 is a very special number, okay? So what you guys wrote here, the fancy way of saying the zero product rule is to set each factor equal to 0. Like in normal people terms, either part of the problem has to be 0. So we're going to figure out what makes the first part 0, what makes the second part 0, and those are our solutions. What are your questions on the zero product rule?
We'll get some practice. So.
All right, so this is a big deal. So in your notes, write the words big deal. I've said it a few times. I'll probably say it 10 more times today. This only works when it is a multiplication problem that equals 0. It doesn't work if you're like dividing or adding or subtracting. Only works for multiplying. Only works for 0. Technically, I guess it would work for division as long as it's the numerator. But we're not going to get into that, okay? Just for this class, remember it's multiplication equal to 0. So go ahead and write this down. We have a problem on the board. It's written as multiplication, right? This is x times x minus 5. And it equals to 0. So it does fit the criteria for the zero product rule. We're looking at multiplication. We're equal to 0. The way we're going to do this is we're going to make each part of the problem equal to a 0. So I'm going to write two equations, either the x equals 0 or the x minus 5 equals 0. So again, these two quantities are being multiplied together. We have a monomial times a binomial. Everyone agree with that statement? In order for them to equal a 0, either this part has to be a 0 or this part has to be a 0. So there's two possible scenarios where we would get an x value that makes this true. Either this is 0 or this is 0. Now we have to solve. Solving equations is what we did in chapter 2. That's where we get the x part by itself. So is the x already by itself here? Yeah, so this is actually one of our solutions. You can box it in. That part's already done. Back here, the x is not by itself. How am I going to get it by itself? You undo minus by minus?
Or add the 5.
Yeah. To undo subtracting 5, you add 5 to both sides. These 5s go away. You're left with just x equals, what is 0 plus 5? 5. So those are your two solutions. If you plugged a 0 in here, you'd have 0 times whatever you would get in here. That would be 0. If you plug the 5 in here, you'd get 0 in here. So either way, you get a 0. Any questions? Now, some students will only give one answer and they'll be like, well, that's right. You have to give both answers. They're both solutions to this problem. What are your questions?
Is everything going to be an X?
I think so. But yeah, this would work for Y's or W's or P's.
Okay.
All right, here is number 2. So take a second to write this one down. Again, we have a problem that's written as multiplication. Parentheses is another way to write multiplication. So we're multiplying x plus 7 times x minus 1. And it equals 0. So this is a wonderful candidate for the zero product rule. What are the two things I need to make equal to 0?
The X.
The what?
The X, right?
The x.
And the addition and subtraction?
Yeah, so the x plus 7 could equal 0. Or the x minus 1 could equal 0. So I'm going to write those two equations. X plus 7 equals 0. X minus 1 equals 0. But I'm not done because the x's aren't by themselves. How do you get the x by itself? You subtract 7 from both sides. What is 0 minus 7? Negative 7. Back here, how do I get the x by itself? You add 1. What is 0 plus 1? 1. Now, you might be noticing a pattern like when it's plus 7, my answer is negative 7. When it's minus 1, my answer is positive 1. That holds true for these. The only time that would not work is if you have a number in front of the x, a coefficient, so be aware of that. Alright, so we have 8x times x minus 10. What are the two things that could equal to 0?
X.
Yep, both parts. So we could set 8x equal to 0. That'll give us a number that works. We can do x minus 10 equals 0. That will also give us a number that works. Okay, so Aaliyah wants to do the back first, which is fine. Add 10, so x equals 10. Anyone know how to solve this equation? Yeah, divide by 8. What do you get? What's 0 divided by 8? 0. That's actually like a mini zero product rule, like what number times 8 would give you a 0, right? It has to be a 0. So those are our two solutions here. So if you plug a 0 in, you'd get a 0 up front. You'd get a negative 10 in here. That's not super important because 0 times anything is 0. Back here, if you plug the 10 in, you'd get an 80, not important, times 0. Anything times 0 is 0. So these both work in this equation. What questions do you have?
Everybody feels okay?
So we have a multiplication problem. We have 5 times x plus 3. And that equals 0. So this is a perfect candidate for the zero product rule. What are the two things I'm going to set equal to 0? 5 and x plus 3. So either 5 equals 0 or x plus 3 equals 0. Something doesn't quite feel right. What's going on right here? How do I get the x by itself? There is no x. What are you getting by itself? Very good. What are you getting by itself? Nothing, right? There's no variable to solve for. Does 5 equal 0? No. So there's actually no answer for that first equation. There is no way to turn a 5 into a 0. There is not a solution up there. And there is not a solution for the very reason that Naya just said. There is no variable to solve for. Okay. The girls in the middle. We got it. All right.
No, you didn't.
Oh, still recording. Still recording. How do I get the x by itself in the back?
-3.
Yes. To undo adding 3, we subtract 3. What is 0 minus 3? Negative 3. So there is only one solution here. We'll look at this type of problem a lot more tomorrow. So you'll see once we write it without the multiplication before we factor, you'll see exactly why there's only one solution. But for today, just recognize that if there's no x, you can't get a solution up there. You can still get a solution in here, though. There's only going to be one solution. What are your questions? So this is one where you won't have two solutions. The next one, you also won't have two solutions. Are you ready to see it?
No, you got this.
Yeah, this one's not bad. How many solutions do you think we're going to have? I already said we're not going to have 2. 3. This time we're going to have 3 solutions. What makes this 0, what makes this 0, and what makes this 0. In this class, we don't do a lot of 3 solution problems, but I do think it's helpful just that you know that they exist. So that's why we're looking at this example. So what are the 3 things I need to make equal to 0?
3x equals 0.
3x equals 0.
2x plus 7 equals 0.
2x plus 7 equals 0.
X minus 6.
X minus 6 equals 0. Wonderful. I'll give you a second to catch up, and then we'll solve those 3 equations. The first one and the last one you can probably do real quick. How do I solve that first equation?
5 by 3.
Divide by 3. What's 0 divided by 3? 0. So I have 1x equals 0, or just x equals 0. Good. Alright, that middle one's a 2-stepper. How do I start it? You undo adding 7 by adding 7? Yes, we're going to subtract 7 from both sides. So we have 2x equals 0 minus 7 is negative 7. Good. Then you divide it by 2. This does not divide equally, so you can leave your answer as negative 7 over 2. If you want to type it in the calculator and give me a decimal, I won't mark you off, but you're just doing more work than you need to. All right, and then the last one. Plus 6 plus 6. So x equals 6. Good. So again, the 6 would make this part 0, the negative 7/2 would make this part 0, the 0 would make this part 0, and if any part is 0, the whole thing equals 0. Raise your hand if you have any questions. All right, last example of the day. Yes? Okay, I agree that something's not right, but it doesn't really have to do with the x side. It equals 18. Now, do not write what's about to pop up on the board. This is what I see all the time. They'll be like, oh, x plus 5 equals 18. X minus 2 equals 18. The solutions are 13 and 20. Why doesn't that work? Yeah. There's no such thing as like, oh, if you're multiplying to 18, one of them has to be 18. That's not a rule, okay? There is no such thing as the 18 product rule. That's what I want you to write on this example. Right? There is no such thing as the 18 product rule. This rule does not apply to problems unless it equals 0. So if I ever try to sneak one in on you that equals a number that's not 0, just tell me, hey, I can't do this. We don't know this rule. All right, do you guys have any questions on what we've discussed today?